what that means is there's going to be huge amounts more manufacturing that's happening. These aren't systems that already exist that you're updating. These are systems that are requiring huge amounts of capital to build up. So the concept is, if we're going to be building it up, and the goal is energy security in any region, then you want to build something that is going to last.
Welcome back to the Clean Techies podcast, where we interview the top climate tech founders and investors to share their stories, advice, and lessons when it comes to building and investing in climate. Today we have a pretty cool conversation with a deep tech founder. We are speaking with Virginia Klausmeier, CEO and co-founder of Sylvatex, a company that makes precursor materials for batteries in a sustainable way. Another way to put this is that they produce some of the chemicals that are used in the production and manufacturing of batteries. Virginia has a very unique story given that her father developed this technology she's working on and eventually passed away. She decided to continue taking this tech through development and founded Sylvatex. The principle is they're able to produce these precursor materials with substantially less energy and, if I understand correctly, no water. Before we jump into the conversation to hear all about the problem, the tech, and her story, we have a favor to ask. If you listen regularly, please take a moment to fill out our survey to help us tailor the show more towards your interests. You can find the link in the description. Enjoy the show. All right, welcome to the show, Virginia. How are you doing today?
I'm good. Thanks so much for having me.
Yeah, we're super glad to have you. So I guess let's just start out by giving us a kind of a quick one-liner or a two-liner of what is Sylvatex doing?
Sylvatex is making batteries for electric vehicles and energy storage. Lower cost, lower capital, and lower carbon.
Hey there. Are you building a climate tech business and looking for very specialized talent? Consider reaching out to our sponsors, NextWave Partners. NextWave are experts in talent acquisition, recruitment, and retention across the climate tech, renewables, and ESG spaces globally. So if your team is growing or you're looking to make a career change yourself, feel free to reach out to NextWave at next-wavepartners.com or reach out to one of their consultants directly via their LinkedIn page. Very good. And that's not specifically manufacturing batteries, right? But creating products that go into the battery manufacturing, correct?
Exactly. There's definitely key products that go into it that are some of the biggest areas for cost reduction. So that's where we're targeting.
Mm-hmm. Very good. And so, we talked a little bit about this before the show, but I guess generally speaking, let's talk about the problem, right? So why is it so hard to kind of bring battery manufacturing to the US? I actually, on a side note, I spoke with some candidates recently on this topic, but really want to understand why is it so hard to get battery manufacturing in the US? Can you talk to us about that?
I mean, there's mildred of problems. Sort of, the first part of it is that Asia, specifically China, has done a great job at being ahead of the curve on battery manufacturing, battery materials, and processing. So they're about decades ahead of the Western world on all of the ways to do it efficiently and effectively. So actually bringing that to the US, one of the things you have as a big problem is you can't just take what was designed in Asia, specifically in China, on a cost metric and also from an environmental metric and just bring that and just plop it into anywhere in the US. You don't have the same environmental permitting locations. You don't have the same cost of labor. So generally, if you do that, your costs are high. But also it uses too much energy. So that's turning into one of the biggest problems is even if you spec it out and do a paper study, it's pretty high in cost. Your energy utilization is pretty high. So where do you get the grid support? And then there's a pretty substantial amount of usually like water use and waste that comes off that. So these kind of come back to environmental permitting. So that's kind of step one, which is taking the same technology that we haven't built out for this region. The other is infrastructure, which is related to sort of high energy utilization, et cetera. But then it's workforce. So, I think that generally, I'll just speak to North America, but, I think this is very common in Europe too. In Australia, there hasn't been a huge amount of development of workforce for manufacturing, right? And there hasn't been a huge amount of development of workforce specifically in like battery materials or, mining efficiencies and all these areas where, electrochemistry, material science, where you've seen a lot more in Asia specifically, and China's done a really good job of building that out.
So the main really issues encompassing all of it include like the cost, environmental permitting. We actually just had a show, our most recent recording, which isn't out yet, talking a lot about permitting in the U.S.,
Oh.
workforce development and infrastructure. I'm curious which one of those, as you started, felt the most tangible, because I think these seem like pretty big problems. How did you start down this path?
Yeah, I mean, cost is the biggest one, right? Is the technology. So if you can't do something here, even from a permitting standpoint, then you have to work within that foundation. But the other one is cost, right? No one's going to buy at a premium. It's just kind of the general sentiment. I think that's really well known. So especially in these large commodity markets that are fueling energy for vehicles or for energy storage, that's very, the biggest issue. So I think for us, we definitely targeted cost and we said, okay, well, if these processes are done in a way that was efficient in that area, right, where there's abundant low cost energy, abundant like cheap waste, right, and abundant other resources, if we make the processes, or specifically we targeted one portion of the process more efficient, then we're lowering the cost and we're making it viable into this marketplace, right? So it's kind of like a double whammy, but we definitely have always focused on how we mitigate cost reduction, but doing it through making it much more efficient and environmentally friendly.
Hey guys, sorry for the interruption. I just need a few seconds because Soma and I have two quick favors to ask. Putting out the show each week takes about 15 to 20 hours between us, so it's a lot of effort, and it would mean the world to us if you would leave a review and mention your favorite episode. Secondly, if you're not already, go over and subscribe to the podcast on Substack. The content is free, but if you like hanging out with us each week, maybe we're even the kind of guys you'd like to buy a coffee for on occasion, consider becoming a paid subscriber. For the cost of one lavender latte a month, you can help us immensely. Thank you for tuning in consistently and helping us to share our guests' stories. Now back to the show.
So when you take a step back and you're understanding the cost structure of it, before we get too deep into it, I want to take a step back and kind of set the scene a little bit. What was this current state of manufacturing and everything that you were seeing at the time?
I mean, in the US, there was one Panasonic. Right. So I think that when you have an N of one, it's very obvious, right? So you had Panasonic was the only battery manufacturer that was doing anything relevant to electric vehicles. And so, that's you talk to a couple people that work there and, they're the only resources you have in this sort of regionally specific area. And then you have like Tesla, who's done a pretty good job on being ahead of the curve of a fully electric vehicle and how to build out the supply chain. So I think, it's been limited. I'll just put it that way. And then you kind of look back and look at what did other countries do, or sort of what are the other problem sets, or how they're approaching the problem. So Europe was definitely ahead of the curve in how they thought about trying to say, okay, well, we need to really focus on recycling, right? If the whole goal of electrification is to move from a non-renewable resource like petroleum to a renewable resource where you're having the metal ion create the electricity, and in theory that metal can be recycled to constantly be re-upgraded to constantly reuse that, then you need to have better recycling processes and then smarter ways to manufacture from the ground up. So this is kind of the first time, I think, ever where you've had a market this big prior to having the build out that needs to happen to support the marketplace. In North America and in Europe, it's the same, because it all comes down to energy security. And that really was, I think, the touch point for the big shift.
Yeah.
Energy transition.
That's super interesting. I mean, I think one of the things that entrepreneurs will have to face within climate is defining an industry, creating an industry, and in your case, maybe onshoring an industry. So I'm curious, what were the signs that something could happen here from when you started?
Yeah. So, I mean, I guess like the immediate focus was, we're a California-based organization. CEC in California has been pretty aggressive at moving towards electrification, right? So pretty straight on that. And we, when talking to them, sort of, they're definitely focusing on, okay, how do we, with them being like the Energy Commission, and folks, where are you looking at investments all around electrification? So when we looked at sort of the supply chain of this, it was very, very clear that as soon as EV and energy storage was taking off, like the energy revolution, the volumes of material that was going to be needed was going to be significant. And then you look at the battery specifically. So you have the plus sign, the negative side of the battery, and the electrolyte. So there's been a lot of work on the design of the battery pack to make it lower cost, more effective. And that really has got us to a cost curve that's viable, right? But cathode material makes up 60, maybe even 70% of the cost of the battery at times. So, and that's just the cathode active material. And so we looked at that and we're like, whoa, that's a very obvious point. And then you look at the carbon impact of the battery. So when you look at the carbon impact of a vehicle, the battery is the biggest part of the carbon cycle. And when you look at the actual battery, the carbon life cycle of a battery's, battery pack, cathode material is about 50% of that. So, in a no-brainer, dummied down version, it's very high cost and a very inefficient process for making this stuff, right? So then when you double click on that and you look at, okay, well, how is it made this inefficiently? Then you see that, yes, of course, you have to mine material and those things, but that only really accounts for half of the carbon associated with cathode material. Like the other 50% is from manufacturing. And I'm speaking a little bit more towards nickel-based, like NMC material. And so with that, you have a huge opportunity to actually do advanced manufacturing to make known materials. So you're not trying to make a new market, to your point. You're not trying to convince a new market to do something different because you have a higher performance widget that can, you have to make a whole new battery supply chain. We're saying, oh, we'll just make the material you're already buying and dropping into your battery pack. But if we're successful, we're doing it in a way that massively lowers the cost of that manufacturing. So you can influence the cost heavily from a OpEx standpoint. And then you are massively reducing the carbon footprint.
So maybe to try to summarize this. So in terms of the reason why you saw there's an opportunity, right? There was demand for EVs, which created demand for batteries. And then the immediate solution was, let's try to make these more efficient so that they're a better product for the market. Then they got to mass market in places that they were already creating batteries more, like China and other places. And now you're looking to look at that process and see how can we make it more efficient inside of the production of this, of these batteries. Is that a good summary of what you just said? Would you agree with that?
I think a key point that is important is kind of this inflection piece is that there's a huge gap in the actual supply and demand, right? Like, so there's about an 80% gap in the supply and demand curve for 2030, at least in US and I think in Europe, it's pretty similar. So what that means is there's going to be huge amounts more manufacturing that's happening. These aren't systems that already exist that you're updating. These are systems that are requiring huge amounts of capital to build up. So the concept is, if we're going to be building it up, and the goal is energy security in any region, then you want to build something that is going to last. We use the word future proofing, but you want to build something that is future proof. So it's designed now to be most effective and is viable. So you're not wasting all this capital. So you actually have this built-in infrastructure that's best in class.
Okay, got it. So my
so it's a little different. You are right, but I just wanted to emphasize I don't think we've ever been in a position where there's such a big market that is known and you have to build it out.
I guess that's the question I want to ask, is because it seems relatively recent that this idea of bringing things back, nearshoring or onshoring, has come about because of various global conflicts, and you can kind of speculate exactly why. Partially maybe COVID and the lack of shipping abilities then. But in your mind, when, or understanding the space, when did the major shift come that people said, you know what, we're not going to ship batteries across the seas, we're going to build them locally? When did that really happen? Or was it just bound to happen regardless of the other circumstances?
COVID. It was binary. So you can look at our grant applications at NSF, who was our first early funder of this work. They're like, convince us this matters. And we're like, okay, there's a battery. People care about them because of this is going to happen someday, right? And then you could just cut out the story. So then, with COVID, I think that it was very clear that there was a lot of vulnerabilities in the supply chains. And then you had that coupled with people caring about environment. So you had kind of a bipartisan, windstorm that happened in probably, all over the world. And then with that came, customer pull for a better future, which then forced the OEM, industry to actually pave a pathway to a net zero future, right? Versus just doing the bare minimum to meet emissions mandates with ICE vehicles or, which there's tons of scandals of actually like falsifying meeting those mandates, right? So that's like, it was definitely pushing the brim, right? So something had to give. So I think that for me, that was it. But
Okay.
that was it. But it was also for me personally coupled with some other.
Hey guys, we need your help with something. In order to better understand what you like most about the show, what you dislike, and how we can help you, please take 7 minutes to fill out our listener survey if you haven't already. It only takes about 7 minutes, but it will drastically improve our ability to give you the best content that you're looking for. Thanks for your help. Now back to the show. Yeah.
Personal growth.
So, okay, that's interesting. So generally speaking, the demand probably would have gotten to this point at some point. Like if there was a massive demand in the US, eventually people would have onshored just to make it more efficient for their supply chain issues. But it really was like kicked into high gear. Everybody said, all right, we can't have this happening again. If we have another global pandemic, we need to sort this. So that would be the big point, right?
Yeah, I think I think that the other component that I really think about specifically in North America is the kind of bipartisan effect is, we all want jobs, we want better middle class. How do we make that happen? What's the industries we're going to invest in? And that's the same discussion that the EU is having right now. And then everyone lands with, well, the auto industry was our founding father of how we all made money, and that was a lot of the foundation. So, I think that there's a lot of examples of where the US gave away manufacturing. And I know, other folks I'm sure talked about this, but solar, all semiconductor manufacturing, right? Like all that stuff has been. So I think that this was where we could actually, potentially get ahead and start securing a position.
Definitely. And I think that's the perfect segue. Now let's take all of this context and let's find out, how did you come across starting the idea of Sylvatex? What is the story of it?
Like the story on, like how far back?
Yeah, how far so let's start from the beginning. Let's go from how it started.
So I started the company with a very strong ambition to massively reduce carbon emissions. And this was, I'd say like early mid 2010s. But I think that was coupled with some elements that are probably important. One, my late father was a brilliant chemist, double PhD MD. So that sort of started the foundation. And I was initially trying to commercialize some work he had developed prior to passing away. So that was like the impetus. Where we are today. And I think that, this has not been, if you, anyone that knows me, this has not been sort of, I went to do my PhD and I founded the company out of that process of a founder story. This has been, I had this really big problem that my father set off to solve, was transportation emissions. And I started the company with that. And then we shifted and we pivoted to the battery industry because that is the biggest bottleneck in how to curb emissions for transportation and energy. So that's definitely where we are today.
So you had this unique start where you end up in a situation where perhaps it's out of homage, perhaps it's out of, the opportunity and shared interest in the thing that you were developing that your father worked on. You now have access to this research. And I think, it might be a unique situation for you, but a lot of climate technologies will come out of commercialization of PhD science, of university science, of different labs. So I think it's actually in some ways, there's a lot of commonalities. How did you go from now, okay, like there's this brilliant people thinking these brilliant things. I want to make this something that I can take to market. How did you start with the idea of I'm going to make a company out of this?
Yeah. I think for me, if I distill it down, it was like, comes down to a little bit of disappointment was, I realized I was at a stage in my life and career where I just realized, I think there was this concept earlier on that other people are solving these problems, right? It's kind of like the older I got and the more access I got to kind of executive functioning or higher up in like these like organizations and insights, I realized actually people like, there's a lot of people asleep behind the steering wheel. And I didn't, I think that like for me that led to disappointment. And it was like one day I just realized, man, the world is not going to change the level it needs to unless we, meaning I, probably need to get more aggressive, right? So I think that was a really big pivot point. And then it was sort of coupled with, I have this potential magic wand that I've been gifted. If I don't even try to make the world a better place with this, like, with this privileged position, then how will I ever be able to sleep at night or, potentially like feel good about myself on my deathbed?
Yeah. I mean, it's sometimes people think it sounds dark, but I think it's very interesting to think about our impact, right? This is like, it's more philosophical than this podcast is for, but I want to talk about you kind of going from that desire to make things happen. And then did you have any particular roadblocks to making it happen, to actually starting and raising money and getting commercialization going, whether those were roadblocks of the, just the difficulties around fundraising, or maybe mental roadblocks where like, I don't know, is this really for me? You talked a little bit about it, but I think that leap from not being a founder to being a founder is like a pretty big leap, especially the first time. So I just want to understand that.
Well, it's super funny the way that you talk about that, because I actually didn't have like, I only saw roadblocks. I didn't see any light at the end of the road, besides just, so I think that that's why, like, it came down to fear. Like, as I distilled it in my mind, like, why wouldn't I do this? It was like fear and faith, right? So in all purposes, like my father and my experience of the world thus far was, and he was a pretty important component, but he had kind of like failed on the business side, right? He was super smart, but he had failed, right? So I wasn't one of those privileged people that had all these examples of success in front of me. I was like really good at athletics and other things like that. So I had personally felt like what it was like to win and different things. So I was like I had a lot of internal drive and motivation, but yeah, I only saw roadblocks. I didn't see, so I think that was where it was like literally a leap of faith was, and that came from probably seeing, sadly, like death, right? It was this concept of we are a finite, like life is finite. You have a short amount of time. What's the impact you want to make? And really looking at that and dissecting it. And then the other side of it, so that's faith. The other side of it was fear. Was like, okay, what are my fears? And really trying to work through my fears. Fear of failure is the biggest one, right? Again, I want to be successful I want to have a life that really creates impact and change. Like, it's like not a small bar that I wanted to, like that I feared not being able to meet up against. Not even the bar that I could think of now, right? So this is before. Now my bar is way higher. I want everyone to change and a lot of things to change, right? A lot. But for me that was fear and like in my ability. So I put myself, before I started the company, I was like, okay, what is something that's really, really hard that I'm very scared of? And I learned about an Ironman. I saw somebody that had a tattoo of, 102.3, 100 something like that on their arm, and I learned about an Ironman race. And once I heard that, I was like, oh man, if I can do an Ironman, then I could start this company and probably not fail.
Oh, definitely. I definitely think it's true.
If you can put the logic together on those two, that's like a whole psych class. But so I did that. I was like, okay, well, I will quit my job if I can do this Ironman in 9 months. And if I can do that while traveling internationally for my job and figuring out how to do that, then I will quit my job that's like highly paid, really nice pathway to go to this like unknown and try to like jump off this cliff and build a plane while
I love it. I really appreciate you walking us through that. Thanks for the insights there.
Totally.
I think I appreciate the realness of how it started, because I think some people like to come across this as, okay, the story is that there was an opportunity right now. This is how I fundraise. This is how I go about it. If I treat it as something more serendipitous, it may not seem as legitimate. So I appreciate you embracing a lot of those parts of the story as well, which is it doesn't all happen in a vacuum. It's not just one big success story of how I got this going, right? And I think that's something that, especially with climate, people are getting more comfortable with explaining that, like, hey, there's a real, climate concern. And sometimes it just is that, one of my favorite other publications in Climate Papa, it really was him having the birth of his child, right? To really take that impetus. And sometimes it's nothing more. So it's not
Well,
something we get to hear every show.
totally. Birth and death, man, are very important. I mean, I
Yeah.
think that like that was like, my impetus started with death, right? But then
Yeah.
since then I've had two children and it's sort of like it re-upped me,
Oh,
right? My
yeah.
conversations, like yeah, they were like different segments of like one was during COVID and one was just before that. So it definitely but it re-ups your
Yeah. And one thing I'd love to do is also shine more light on the brilliance of the technology itself. So,
yeah.
in a very, very, very high level, what really is the unlock of a waterless sort of cathode active material within these batteries? And what did you have to change along the way? Of course, there's a lot of science behind it, but what were at a very high level, what was the major unlock that made this happen?
Yeah, so I think I'm going to start a little bit with the end product is cathode material, right? So we're making the high performing cathode materials that go into electric vehicles. Our goal is to make kind of all chemistry, so be chemistry agnostic. And that was really important. When we looked at the system that was broken, it was broken by a couple different ways, right? So this is specifically cathode, making cathode active material. It was broken in that it it used a huge amount of energy. It was a multi-step process and it had to use highly pure mined and refined material. So there's sort of two pieces of that we really drilled onto. One was opening up the inputs that could be used from either less mined or broader stream of inputs. So working with oxides and hydroxides, so you don't have this sulfur molecule that ends up being the big waste component that is like a really big problem with scaling in industry. So how do we design that out of the process from the upfront that ultimately will make a much more streamlined input side from the mining and refining, and also not have that inherent waste? The other was being able to incorporate more effectively recycled materials. So being able to have a process where you could combine all the metals in one step. Typically, like in existing manufacturing, it's a multi-step process, and then you add the lithium. So when you're recycling material, that means you have to extract everything out into highly pure materials, again, that you spend all this energy making. So for us, we can combine that just directly. And then the third piece was making it in an environment or a way that was going to not require water. So our kind of unlock was allowing for a natural-based material that we incorporate with all of the metals, so the nickel, lithium, etc., and it allows it to combine together to make it more homogeneous. So all that means is mixed well, and then that allows the process to be more simplified. So we used, we looked back from all of industrial manufacturing, and we used just basic industrial manufacturing tendencies, which is a more homogeneous material makes the process much more efficient. So that was our step one, was broaden the range of inputs, make it a more simple process. And then we gave ourselves the extra hurdle of using off-the-shelf engineering equipment, because a lot of advanced manufacturing designs use new equipment, which is peppered with problems. Mostly like, later, like as a business model, you might have to be an equipment vendor. You have separate from like supply and problems with that. Then you also have like variability in each level of scaling. And so we really wanted to stay focused on how do we get to bankability and stay in our lane and only focus, like not look at like how to make new equipment, all those things, just use the equipment that's currently available, but then make a streamlined process that's best in class, that from a point of low cost and has no waste, uses a variety of inputs, and is also flexible from a chemistry
Guys, so that's a lot. I'm going to try to get this right. Okay. Let's see. So generally speaking, you were thinking about the fact that there's inputs and you're trying to make these inputs more sustainable. So what you did to do that is you widened the raw materials that can be going in and the process of making them. Those are the two things you changed. Okay.
You're hired.
Got it. So you did those two things. Now, how does this fit into the battery chain? For some people, you're not familiar, explain to me like I'm 5, right? Like you take X, do X with it, and then you sell it to this person who then does this with it. What does that look like?
Yeah, so just to give some touch points for the battery supply chain and for most things, you have the input materials. So these are the metals that are mined and refined or recycled, right? And then we use those, and then we bring them together to make this end powder that is the plus sign of the battery pack. It's called the cathode active material. We sell that, or that gets sold to the cell manufacturer who makes the electrode, and then they make the whole battery cell, and then they sell that directly to the end OEM or the end vendor.
Perfect.
So that's the kind of the general sentiment. And then we can talk more about the dynamics of the pool and the different things.
Yeah, that makes sense. So I guess then, there's probably so many things. I'm always very fascinated by technology, so I could ask questions for days about sourcing everything. But Somil, do you have any particular things that you want to jump in terms of the technology to understand, or have we covered it pretty well?
I think that's super, super helpful. I'm wondering, when you made this material, what was the part of the supply chain that you went to market with? Like, how did you essentially get this out there?
So one of the key things that I think is super important, just kind of like backtracking, is that when industry focused on moving to electrification, they had a net zero goal, right? And just to kind of ground you, it's 100% impossible to get to the net zero goal with existing manufacturing of cathode material. So either way, separate from all the things we talked about at the beginning of the podcast, something has to change. Like, you have to change the manufacturing process. So for us, that's been the key element. We've gone directly to the EV OEMs and said, okay, you have this EV future pathway, and you are making EVs now, and you're using these materials in the batteries. How are you counting your carbon, and how are you counting your costs? And then how are you going to do that in North America?
Yeah.
And the next piece was, do you want to do that lower cost with lower capital with lower carbon?
Okay.
Yes.
Of course. So I want to clarify then. So how is it more environmentally friendly? You said that you use less water, you use no water. I want to make sure I understand this correctly. Obviously there's some IP you can't share, but just generally speaking, how do you make it with less water? Because that's the main efficiency, right? Less water and less energy.
Well, actually, the main efficiency is cutting out a lot of steps. So I think this multi-step process, that when you think about water and when you think about it in manufacturing, it's actually tankage, right? So if you're taking a tankage where it's like 90% water and you're putting 10% materials in it that then are combining, then you're using a whole bunch of wasted space, right? And so we actually took that all out of the equation. So it kind of came together with, if you don't use water and if you use oxide materials, then you can, like, lower the footprint substantially. I'm sure you're familiar with dry electrode manufacturing, and that's the exact same kind of thought process. With dry electrode manufacturing, you're not using the solvents and all that volume, so your footprint is way smaller, and your CapEx install is like a fraction. And we're doing the same thing, but for cathode manufacturing.
And your long-term goal of the company generally is to do take a lot of these different technologies and make them more efficient, skip the steps, reduce the energy usage and water usage, et cetera. Not just for what you're doing now.
Good question. Right now, if we can solve this problem for even a sliver of the marketplace, we make a substantial amount of, it's like billions of dollars in revenue, and it's a substantial change in the carbon footprint. So I think we're definitely very focused on this industry, just to and different parts of this industry, because we see it as one of the biggest growing ones. And whenever we've looked at other industries, it's like a drop in the bucket in the compared to the futures of kind of cathode material production. But back to your point, you are correct that we could take a lot of the knowledge that we have advanced in the manufacturing process and apply it to other areas that are probably like looking at metals and other materials and combining them in a much more effective way. So like catalysts and those things, like, a lot of different processes
Okay,
probably
got it.
within
And
the
then the
different
model will be to produce
markets.
these materials and then sell them, or are they going to be produced on site at the battery OEMs where they're making it? Is that the objective, or just to produce it and then ship it where it needs to go?
Good question. I mean, a little bit of exactly where it's going to be produced at commercial scale is going to be dependent on how the marketplace starts to really pan out. The piece that we offer is having, at least like a 50% cost reduction in CapEx, which means that you have more optionality of being able to place it, and we use way less energy and no water, right? So that means that in the first time ever, you have the concept where you could potentially coordinate with upstream. So that means like coordinate with recycling or feedstock producers, and then upgrade it to higher value cathode material, and then send it to a battery cell manufacturer. So that's one option. The other option, of course, it's more efficient to be close to either your end customer or your raw material provider. So those are kind of, to your point, the primaries. The other option is to vertically integrate with the cell.
Okay, interesting.
Cell manufacturing.
That's quite fascinating. I guess I didn't think about that, because just to clarify, because it's lower cost, it could be built closer to the inputs and the outputs, or either or, basically. So that's interesting.
Well, I would say lower cost. And even what I'm hearing now is it's mostly just the energy, because the energy draw is one of the biggest problems. So like you can't have an energy intensive cathode manufacturing next to one of the most energy intensive cell manufacturing sites. There's not enough load, right? So your nature, like you're already going to have this distributed network, because it's going to be around energy, right? Which is why you're having a bunch of utilities getting involved in the supply chain, and a bunch of government getting involved in like how we're going to fuel this and make it efficiently. So I think that that's one of the, what I'm seeing is like people like met with the Canadians and different folks, and they're like, okay, but really how much energy do you use? Cause we're really excited to use low energy. I'm like, and then they, and they're like, cause then that means you could site next to all of the battery manufacturing that's going to be here. And because they're like, we only have this much grid to give you, a very small amount. So that's what's exciting, is it allows you to unlock. And then the water utilization too is a big problem. So that's usually a rate limiting step at where you can do things. So we kind of take all that out of the equation. So it gives us a lot more optionality to maximize off of carbon footprint and cost efficiency.
And then just to clarify, we'll go through this really quickly. Where is the company today in terms of development, right? Do you have a pilot project going? Like what is the general kind of status now? I'm assuming I know you guys have raised money. So just kind of tell us like the general state of the company today.
Yeah, completely. So we're at this beautiful state where we found wonderful product market fit. We have a significant focus on key materials that are supplying that market. We have two different, typically cathode manufacturing hasn't been flexible. So we have two different proof points with core materials that show the breadth of the flexibility. And we have a pilot, as you mentioned, where we're making hundreds of grams and moving to kilograms over the next year, and supplying to customer samples. So that's one of the big ones. So we're starting to do a significant amount of customer sampling and working with the end market on validation. And then the sky is the limit on the next step.
When it comes to communicating the success of the pilot, what are you tracking? Is it basically fulfillment, or what's the structure around that basically saying that this is working?
Yeah, so you have, the good news is that the end materials, usually you have like a pretty tight specification with like, any OEM. They're like, hey, if you're making NMC, whatever stoichiometry, this is like we look at the specs, and you have a pretty good target range. So that's like, an end spec of a material. Can you make the material that we want and is designed in general? And then you look at, okay, well, can we be using equipment that is off the shelf and standardized and is a mini replication of something that's going to be big, the next big size. So we've actually done a huge amount of effort this last year to figure out what pilot scale looks like to support the commercial demo that allows us to go from that very low cost commercial demonstration to an actual fully commercial capability that can be financed in multiple different ways, right?
Very
so
cool.
It was working through that process backwards, to your point. And so that means the pilot is a mini replica of mostly using processing types of equipment that can be scaled up efficiently for commercialization.
And I want to talk through the resources that you pulled together to get to this piloting stage. The
Mm.
reason is that the point where you're at is a point that many climate companies are at. I think is equally complex for everyone. So what was your fundraising history like in terms of getting capital and resources together? And also, what's the structure of the pilot? Pilot structures are very different. So to whatever you can discuss, if you were thinking about equity, if you're thinking about cash, what does your fundraising history look like up until now?
Yeah. So the way that I've really cared about kind of like public-private money to finance, early stage, but probably ongoing in the space, mostly because I think that there's a duty on supplying sort of government resources. So we've done a lot with working with government institutions on financing and supporting our early stage. So we have been awarded quite a few grants on the early side. And then we have coupled that early on. I actually had our early investors were more high net worth individuals that were self-made, right? So it was using them as mentors as well as capital, because that's the best way to get capital is like someone who's smart, who knows how to solve your problems, have been there before, and they have money. So take their money, then they're more willing to take your calls. And and they're very helpful, and they were very helpful on just kind of getting us to the focus point, right? What is really the focus that you need to get to? When do you know that you're focusing on a product market solution set that's really going to be the impact that you're looking for and is big enough and yada yada, right? So that's really where we got our first capital. And then for Series A, we definitely brought in a bit more institutional investors they had a lot of knowledge and are pretty good investors in the energy storage space. So, I think that was wanting to get our grip a little bit more connected to parties that know business in the sector and just have a pulse to the ground. And now the next step is really going to be looking at investors who know how to build stuff and actually look at how to build stuff that is going to be in a way. So how do you build a business at an early stage where you're not raising so much capital that you can create a lot of optionality in exit opportunities or scaling
Yeah, this is helpful.
capabilities.
So no, I
Happy
think
to
that's good.
digest
So
that more
generally
if you.
speaking, to kind of summarize, you did utilize grant funding to get to where you are now, and some investors at the beginning, obviously. But the next stage is now that you have product market fit, you have probably some LOIs, people very interested, you're doing some stuff. You are now, or either now, I don't know if you can talk about it now, or have already raised very soon, probably, the money to go for a pilot. And I guess my big question is, what are the milestones usually to get to the next thing, right? I don't know exactly if you've already raised the money for the pilot, but to get from that pilot to the commercial phase is a huge leap, right? So can you talk about the
Yep.
milestones of what has to happen in order to get there? And also would like to know what type of investors will come in at that process.
Completely. So, and this is quite honestly what we spent all last year figuring out, right? So, first off, you say, okay, what does commercialization look like? Okay, for us, it's modular. So you have a line size that gets figured out. For us, it's somewhere between 10 to 15 KT, and then that just gets build, repeat, and that's actually how it looks at large scale. Is you have multiple lines. Right now, the rate limiting step, of course, with that line and the multiple line scale is because of all the waste. So that we don't have that rate limiting step. So technically we go from one line to having a huge production site, if you like. And then you can finance those in a different way. So all of that, the goal is to say, okay, how do you finance that first line? And then and that's it. There is buckets of capital for that, which LPO and other funds, are very good examples. And then you go from that to say, okay, well, if that scale of around that line, typically they want to see like 10 to 100x maybe of like a commercial demonstration. And especially if we're using off the shelf engineering equipment, we minimize a lot of that risk, right? So then we actually went backwards and worked with equipment vendors and sort of more engineering firms to evaluate what is the equipment we need at commercial scale. And then how do we make that the miniest replica possible that we could do for commercial demonstration. And the commercial demonstration is around squiggle 1 KT, and that is going to be a bankable asset. So that's I think a different way that you ask a question is like, or the way that I pose the question to us and our team early last year was, how do we get to bankability? How do we get to bankability with the least amount of capital possible, right? Because the concept is everything pre that, either you have to have some government funding, or it's all equity, right? So there's been, I know you guys are very familiar with a huge amount of, these very expensive first of a kind plans, or, getting to bankability in a way that's cost efficient, I think is like where people are trying to figure it out. So we did a really good job getting ahead of that last year. And we were early in our capital raising, right? So then we backed into that and said, okay, well then we know that that's our target. Then what do we need to make sure that we have confirmed engineering specs that are, for a facility that's going to work for that commercial demonstration?
So
and that's the
this I
pilot that we're
don't
at
know the
now.
answer to. I've never actually asked anybody this, is how, if your manufacturing process is something that's going to be a modular, so you can just like say you want 10 or you want 100, whatever you want, is that an asset where you don't actually need to raise equity to go do this, or you don't just do purchase orders, you can actually just raise a debt facility? Okay, got it.
Correct. Yeah. Yep. That is, I
Yeah.
mean, that is like private equity debt model. Like we already have like millions of people swimming after us to finance those assets. It's very exciting. They're smart because the margin potential on them is astronomical and the sky's the limit for the end product. So it's exactly what private equity or
And
debt
that's
financing would want
because
to run after.
this is despite the fact that you will be producing the end products. You're not licensing the IP and the technology. You're not just selling the equipment and the IP. You're actually producing the end materials, correct?
So short answer is yes. Though as far as we can see is the commercial demo. We will produce a commercial demo after you prove out and validate and completely validate the techno-economic assessments and the margins, and you mitigate all of the technical risks. So that's bankability. So after commercial demo, sky is the limit, right? Because then I can do licensing and say, hey man, this is confirmed. I want like a lot more. If you do it early on prior to proof points of scaling up, it's sort of the cycle that you see parties like 24M and a bunch of other organizations that kind of have gotten into, where they've licensed technology prior to scaling
Disaster.
it or proving it at a commercial scale. So, well, you don't, there's a lot of things that it's still in a development element, right? You still have things to figure out. So, we've tried to be very thoughtful to, again, this is all coming from a place like, yes, we want to make a bunch of money, but for me, it doesn't matter unless we're scaling something that's effectively can scale. And also if it actually reduces the cost and actually reduces the carbon to the level it needs to, because so none of it matters. So we're trying really good to be smart about not just satisfying what kind of investors need us to tell them at that stage, but actually getting conviction ourselves at each stage of the game to make sure we're walking into the marketplace with the best.
So the reason I was asking
possible.
that was mainly because I know it's not technically a pure commodity you're producing, but I wasn't sure that debt would ever finance something that's a commodity-based market. If it was an equipment sales, that makes sense. But I understand. I just wanted to make that clarification.
Yeah, we're not an equipment. We're not like cathode material is, I think, is probably gonna continue to probably be labeled as more of like a specialty or high value chemical space. So versus a commodity market. I think that, over time it will shift to that, but definitely with the inputs, you have.
Got it. All right. We're definitely over time here. I want to just get this thing pretty quickly to finish this off here. Obviously, building this kind of company is difficult. There's a lot of unknowns, especially for somebody like yourself who didn't necessarily head down this path kind of early on with your education journey. You weren't specifically trying to do this. How do you as a founder navigate the unknown? Like if there's any particular tactics you have on how to not get overwhelmed by the things you don't know and understand, where do I need to be looking to know what I don't know, et cetera. Just talk us through that process as quickly as you can, but still, give us the insights.
Yeah, navigating the unknown, sort of the first is like really qualifying what is not known and what we need to know. So I think that like we've been very good at, I don't want to do anything, like literally spend any time on something someone else has solved. So that goes from setting up the company to how do you set up a company most efficiently? How do you set up HR? How do you do review processes? Like all those fundamentals, like we're not going to spend the time to do that in a brand new way that's going to be best in class, right? We're going to take, you scour the world on what's going to be best in class, what's already there, and then you implement. So I think that that's been really good for us to then clear out and create the white space and say, what is the thing that we're uniquely focusing on that is really important? And if it's something else that someone else can do, then work with them. Some parts of it, just trying to chip away at that constantly. So you kind of go, when you start a company, you go big because you have so many things you have to do. And then you like a laundry list of all these elements, and like literally you just put them in buckets of what is known things that I can hand off or other like can be solvable. And then you get really, really clear at the unknown, and the way that I've like what's really unknown and really where the white space is that you're solving for. And the white space concept for me has been really valuable. Because if you think about, artists and a lot of different where, areas where you go to silence your mind to invoke creative capability, it is having white space. And for us, that is getting really clear on just the very, targeted area that no one's looking. So no large organizations looking at, that we are going to chip away at and do best in class.
I think that's like it basically emulates that sort of approach where you could get distracted on the sides, but it really is just about your core product at the end of the day. So focus on that and that alone, and everything you should do should focus on that. That's kind of what I heard from what you were saying, especially because
it is like a constant iteration. Like, what's the core product? What is the core thing that you're good at? Because you might have people that like can help, like, or things that are invented along the way that can support that core product in some component. So I think that's really, really valuable for us on navigating the unknowns. And then the other standpoint that I've had that's been super useful is just realizing that, no one's ever done it before, right? So you can get advice on, figure out where advice is useful, right? So on a lot of areas, it's super useful and it's very tactical and just, solve those problems with known positive, approachable ways. But for when it comes to actually how to do this one thing, like there's probably like maybe one or two or three people who've thought about it, not thought about it for days, but find those few people who have thought about it and get them in a room and pay them to be your advisors and, and work with them, because that's really where the key magic happens.
Amazing. Well, we really appreciate this. I know, like Silas mentioned, we're pretty much over time, but again, really appreciate you sharing the story with us. I think it got a lot more complex than we even thought it would, and I think that just shows that you're tackling a really big problem. So before we shut off, we'd just love to ask, where can the audience find you?
Sylvatex.com. I'm also on LinkedIn, Virginia Klausmeier, and my team is all over LinkedIn. That's kind of our one little place that we go.
Amazing. Well, thanks so much for coming on.
Thanks so much for having me.